Good morning, everyone. My name is Ashok Samal, and welcome to another cool demo video of Redhat AI. And this time, we will do it together with N8N as your low-code, no-code platform hosted on top of Red Hat. Last week, I was in Johannesburg meeting with a few of my top customers in South Africa. I met with 6 customers. 3 of them were telco and 3 of them were banks. And I had this one question for all of them. Tell me the number one use case that you would love AI to solve. And if it solves, then you will tick one of your KPIs for the year. And no doubt, 5 out of the 6 customers said AIOPS is their major use case that they would love AI to fix. And the reason behind it was very simple. They all are running mission critical use case on their platform that produces a lot of log files. And because these applications are mission critical, they cannot afford to let it down before a crash occurs. They want to catch the anomaly and put their engineers to work so that the downtime never happens, so that that application never goes down, because these are mission critical use cases, mission critical applications. Without wasting any time, let's straight jump to the demo and see how Red Hat AI can help you achieve that goal. And like I said, we will be using N8N as your no-code, low-code platform, which is totally hosted on Red Hat AI. Let's dive in. We will keep today's session very simple. So we have Red Hat OpenShift, and on the top of OpenShift, Kafka is running. Also, N8N has been hosted on top of OpenShift. So N8N is running locally on top of my cluster, right? We are also having Red Hat AI running on top of OpenShift, and we have set up model as a service, right? To achieve my workflow where a mission critical application is running and producing a lot of log files. A Kafka topic is getting these log files, and it has been processed using N8N workflows. What we are doing is we are creating a 5 minutes aggregations of this Kafka topic before it can be forwarded to Red Hat AI model as a service. And in this demonstration, we are using Kimi 2.7 as our LLM model. So Kimi 2.7 model will consume this 5 minutes aggregations of the log files, and then it will produce an output which will predict if there is an anomaly. The objective is very simple. Even if the log is not giving us a warning or an error, even if the log says it's absolutely fine, can we anticipate a critical application failure which might happen in next half an hour or 1 hour or something like that? If you know this front end, we are right now on OpenShift, right? If you go to the pods, you can see here, Kafka is running right here, right? My Kafka is running on one of the pod. And we also have N8N right here, right? Let me go to the terminal and let's see if N8N is running local to us or not. We can see here N8N is running, and similarly we can see if Kafka is running here or not, right? So Kafka is running. Now let's go to OpenShift AI. This is my OpenShift AI. If you go to AI asset endpoints, so here I have access to Kimi 2.7. And I can go here and get my keys for Kimi 2.7 because I have model as a service enabled on my platform, right? So I can literally go here and get an API key to access Kimi 2.7 right now for my applications, right? Let's jump to N8N right now, right? This is my N8N, and if you can see here, it's running on top of OpenShift. And on N8N, I have set up the complete workflow here. Number 1, Kafka trigger, right? So this is where all the Kafka messages are coming in that my application is producing. If you can see here, these are the Kafka messages, and this is our trigger point. Now, what we are doing here, we are preparing a 5-minute Kafka batch, and this is where we are creating the Kafka batch here, and we are also providing the config for our LLM endpoints. This is our LLM endpoint for the Kimi 2.7, and this is what the model name, and this is the API key, right? And once this 5 minutes batch is produced and once this configuration is passed, then we are building the LLM train request, right? So this is used to prepare the message so that LLM can consume these messages as input, right? So I have the complete logic written here. Now, once the messages are prepared, then we are calling the Red Hat AI model endpoint, right? So this is where the Kimi 2.7 model is getting called with the 5 minutes load of the Kafka messages, right? Once the Red Hat AI model gives the output, we are basically getting the JSON, and we are parsing the JSON message, and that is the LLM predictions, right? Once this predictions is coming out, if it predicts it as anomaly, then it is formatting the alert and preparing it to be sent by the email. Here I'm using my own personal Gmail ID to send and get this anomaly report, as well as we are also sending it to ServiceNow, right? If there is no anomaly, then nothing will happen, okay? So this is the entire flow. And what we have done here, we are running this anomaly from last 2-3 hours, right? If you can see here, every minute, trigger is happening to this Kafka every minute. Literally in every minute, a trigger is happening here, right? And it is consuming 5 minutes of the Kafka batch and then doing the prediction by using Red Hat AI model here, Kimi 2.7. If there is no anomaly, nothing going to happen. If there is anomaly, it's going to send an email as well as send it to ServiceNow as a new incident report, right? Let's find out one of them, which is anomaly, right? So for an example, if you see here, this ran at 6:52, and if you can see here, this is labeled as anomaly, and right now the emails should be there as well as a ServiceNow incident should be there, right? So if you can go in and also see here, right? So the email has been sent, right, to my personal email address, as well as a ServiceNow ticket has been created with number 10062, right? Now let's first go to the email address. If you can see here, this is my email address. If you can see here, AIOPS warning, payment system. I have an application which is a payment system, payment services, right? And degraded, right? So if you can just open this one, if you can see here, the complete report is right here. AI predictive anomaly report. Status is degrading. Remember, right now it has not crashed, right? If you see here, the log files that is used to trigger this anomaly is this one. If you see the label, all of them are info. It's not warning or error. But what is happening here, there is a 68% confidence this application will fail if we don't do something right now, right? Payment service is operating with sustained queue blockage and elevated latency despite successful HTTP 200 response. So even if the response is 200, still right now, a lot of calls has been queued and the latency has been increased, and that is a trigger. And if you see the trend summary, throughout the 5 minutes window, queue depth remain consistently elevated, average 7, max is 10, and ends higher than it started, 6 to 9, right? With respective spike to the maximum value. Latency average 178 millisecond and reaches to 208 milliseconds. So we can see also a spike in latency, right? And there is a simple trained evidence what is happening during this time period, right? There is a few statistics about it, and then the raw log files are here, right? And then AI is also predicting some immediate actions and permanent fix, right? Remember, even if the labels are not warning or error, still we could figure out with a confidence of 68% that something is not right in my application, right? Somebody need to go and check out what is happening and probably implement this immediate actions or permanent fixes to solve this. Now let's go to the incident one, right? If you go here, let me refresh the page. Now, if you see here in the ServiceNow, incidents are getting created. If you go inside this incident, you can see here the same email, right? 68% services, right? The trained analysis, the fix has been suggested, and then it has been created here with priority 3, SLA, right? Right. And then probably somebody will look at it from the support team and try to fix or do something. The downtime could be avoided, right? So in a nutshell, right? N8N is the orchestration where you are doing low-code, no-code platform orchestration here end-to-end. And Red Hat AI is the brain of the entire thing. And the model is coming from Red Hat AI, which is giving you a unified governed AI platform for any of your LLM activities, right? And if you see here, the whole N8N is hosted on top of OpenShift. That means your messages, your logs are not getting anywhere outside of your infrastructure or data center, is sitting right there. That's what sovereign AI data localization means, right? You are not compromising your data sets by sending it to outside of your data center. Now let's go back to our AI platform, the Red Hat AI, and let's look at the observability dashboard, right? So I'm in OpenShift right now, and I'm in Observe, and I'm in the dashboard right now. If I go to the usage, and let me do one thing, let me select my user ID at Red Hat. This is my user ID at Red Hat. And if you can see here, let's make it last 1 hour. If you can see here, in last 1 hour, I have consumed, because I was running this application, this is me, and the model I'm using is Kimi 2.7, and I have almost consumed 1 million token, and I have already sent 121 requests, right? So this is just one application. I'm consuming already 1 million token for this one, right? So this is how AI ops could work in your environments. Of course, AI ops is a bigger topic than only this workflow, because you could consider this as one agent or one tool calling. And if you want to know more about AI ops, want to understand the end-to-end ecosystem of AI ops, then leave a comment below and I will do another session to explore it better. But in a nutshell, we can consume all of your logs that your application is producing, and we can deploy N8N on our platform, which could be your no-code, low-code platform to go, use the models that is running on Red Hat AI platform, and get the anomaly report into your email or into ServiceNow, and then avoid downtime in your application. Hope you enjoy it. If you enjoyed it, please share this video and comment me in the below for the next part of the AIOPS. Thank you very much. See you next time with a new cool demo.